How are you, my student? Welcome to our lesson today. Our topic is Newton's laws of motion. The Newton's laws of motion. That is our topic. And in our lesson today, we are going to look at what we refer to as momentum. We denote momentum using this letter P. We use P to denote momentum. That is momentum. That's the letter that we use for momentum with a small extrapolation here. That's for momentum. So I would like us, by the end of this lesson, you should be in a position to define what is momentum and also do numerical calculations involving momentum. In our previous lesson, that is on the Newton's first law of motion, there are two key things that we noted. And I would just like to do a recap before we define momentum. We said that force is that which tends to change. It is that which tends to change the inertia of a body. The inertia of a body. Anything that will tend to change the inertia of a body. Then we also said that that is one force is that which tends to change the inertia of a body, and we also said about mass. Mass is the quantitative measure of inertia. Now, in our case, this lesson, I would like you to consider the following. I want you to consider the following cases, whereby in the first one, A, we are having a car. Let's say the mass together with the occupants of this car, let's say it's around 800 kilograms. And then this car, let's say, is traveling at 80 kilometers per hour. Then in our case number B, we have a bus. And the mass of this bus together with the occupants, let's say, is 1800 kilograms. And the bus again is moving at 80 kilometers per hour. Now, if we are to stop these two vehicles, the car and the bus, for the bus to stop, we require more force than for the car to stop. Because of the force, the mass of the bus is more than the mass of the car. And therefore, we can see that for the bus to stop, we require more braking force than for the car. And this is due to their masses, because here the speed is the same, that is 80 kilometers per hour. And therefore, we are saying that mass is a quantitative measure of inertia. And therefore, in this case, we can say that the bus has more inertia than the car. The bus will have more inertia. The bus has more inertia compared to the car, because the bus has more mass, and we have seen that mass is a quantitative measure of inertia. So here is as a result of inertia. And again now, we can explain this now using another quantity. We can explain all this using another quantity, which we are referring to as momentum. Because again, in this case, we can consider two vehicles which will have the same mass, but they are moving at different velocity. So we can now apply momentum to explain why for the bus it will require more force than for the car. That is the stopping force. So I would like us to move ahead and define momentum. We should know that momentum depends on momentum of a body. Momentum depends on two factors. Depends on, number one is the velocity of the body. The velocity of the body. The velocity of the body. And number two, momentum will also depend on the mass of the body. The mass of the body. And therefore, we define momentum. Momentum is defined as the product. It is defined as the product of mass and the velocity, the product of mass and the velocity of a body. That is what we refer to as momentum. The product of mass and velocity of a body. And therefore, we say that momentum P is given by the product. Product is the answer you get after multiplication, and therefore momentum is given by mass. We denote mass by m, multiplied by the velocity, which we denote by v. And therefore, we can simply come and see that momentum is equal to mass times the velocity. Momentum is given by mv, where m is the mass, and the mass in kilograms, where in our case here, where m is the mass, and this mass is in kilograms, and v is the velocity. V is the velocity in the SI units, that is meters per second. So that is what we have for momentum, the product of mass and velocity. So momentum is given by mass multiplied by the velocity. Therefore, from that formula, we can get the SI unit of momentum. The SI unit of momentum. SI unit of momentum. We are saying that momentum is equal to mass multiplied by velocity. And we know that the unit for mass is kilograms. For velocity, we have meters per second. And therefore, when you multiply this, when you combine this unit, you will get kilogram meters per second. And therefore, the SI unit of momentum is kilogram meters per second. That is the SI unit of momentum, kilogram meters per second. And again, if you look at this, mass is a scalar quantity, velocity is a vector quantity. And therefore, a scalar quantity multiplied by a vector quantity is equal to a vector quantity. And therefore, we also say that momentum is a vector quantity. Is a vector quantity. And the direction, meaning that it has both direction and magnitude, and its direction is the direction of the velocity of the body. Its direction is the direction, that is the momentum, is the direction of the velocity of the body. So that is what we simply refer to as momentum. Momentum is simply, we are saying that it depends on two factors, that is the velocity of the body and the mass of the body, and therefore it is the product of mass and the velocity of a body, and whereby the mass must be expressed in kilograms and velocity in meters per second, and therefore the SI unit is kilogram meters per second. I would like us to do a question on momentum, calculation of momentum. We can do an example on calculation of momentum. I'd like us to do one question on calculation of momentum. So here we have a van of mass 3 metric tons. We have such a van is traveling at a velocity of 72 kilometers per hour. So the question is calculate the momentum of the vehicle. Calculate the momentum of the vehicle. So I'd like us to calculate that momentum, whereby we have been given a van of mass 3 metric tons is traveling at a velocity of 72 kilometers per hour. Calculate the momentum of the vehicle. So the first thing we need to do is to analyze this question. We get to know what is given and what is in question. So we've been given the body, that is the van. We've been given the mass as 3 metric tons. So we have 3 tons. Is traveling at a velocity. So before even we move on to velocity, we need to change this mass into kilograms, because we are saying that when calculating momentum, mass must be in kilograms. And in this case, we know very well that 1,000 kilograms is an equivalent of 1 ton. And therefore, what about the 3 tons? So we are going to have it as 3 tons multiplied by 1,000 kilograms divided by 1 ton. So we end up getting this as 3,000 kilograms. So we already have the mass. The mass is 3,000 kilograms. Then we have also been given the velocity. The velocity is 72 kilometers per hour. We change now to we need to change to meters per second, and therefore this is the same as 72 kilometers per hour, meaning that we divide by an hour. 72 kilometers per means divide by 1 hour. So this is the same as we now change 72 kilometers into meters. We know that 1,000 meters make 1 kilometer, and therefore we need to multiply 72 by 1,000 to get 72,000 meters all over. This is 1 hour, and 1 hour is equivalent of 3,600 seconds. So when we divide this, we end up getting by that 6, 1 by that 6, we get 20. And therefore velocity is 20 meters per second. So we move ahead now and calculate the momentum. We already have the velocity and we already have the mass of that body. And therefore momentum P will be given by mass times velocity. Our mass here is 3,000 kilograms. We multiply by velocity, which is 20 meters per second. And we end up getting 60, we have here 60,000 kilogram meters per second. And that is the momentum, 60,000 kilogram meters per second. Let's look at another example, example 2, again on the calculation of momentum. Number 2, we have a body whose momentum is 2 times 10 power 4 kilogram meters per second, is traveling at 50 meters per second. So the question is calculate its mass. So like us to do again that other question. A body whose momentum is 2 times 10 power 4 kilogram meters per second is traveling at 50 meters per second. Calculate its mass. So here we have been given the momentum. Our momentum is 2 times 10 power 4 kilogram meters per second. We've also been given the velocity, that is 50 meters per second. So we are told to calculate the mass of that body. So in this case again, we know very well that momentum is given by mass multiplied by the velocity. If we were to draw this or to represent this in a triangle, this is what it would mean. So this is, if we have this, this is our momentum, this is our mass. So this one is multiplication. So we have mass times velocity. So whenever we want to get, for example, if we want mass, in this case, mass therefore will be given by, this is division, this sign here, the horizontal one. The horizontal one is division, then the vertical one is multiplication. So if you want to get mass, you simply talk of now the momentum divided by the velocity. If you want to get the velocity, you simply come and take again momentum divided by the mass. And if you want to get the momentum, it is simply mass multiplied by the velocity. So in this case, we want to calculate the mass, and therefore we can apply this where mass is equal to momentum over velocity. So we are going to have mass being equal to momentum divided by velocity. Our momentum is 2 multiplied by 10 power 4, which is the same as 2. Then we multiply by 10 4 times, so we have 20,000 kilogram meters per second divided by the velocity, which is 50 meters per second. So the meters per second will cancel. Then we'll cancel that by 5, 1. By 5 we have 400. And therefore our mass is 400 kilograms. So that is the mass of the body. That is the mass of the body whose momentum is this and which is traveling at 50 meters per second. Let's now have an exercise whereby now you can work out and see whether you are able to work out questions on momentum. So I'd like to give you 2 questions. Exercise. In question 1, I'd like you to define momentum. Define momentum. Then in question number 2, we have a car moving at 36 kilometers per hour. A car is moving. Here we have a car is moving at 36 kilometers per hour. So the question is calculate its velocity, or simply what velocity will double its momentum. So in this case you are calculating the velocity that will double the momentum. So ensure that you do these 2 questions, you define momentum, and here you calculate the velocity that will double the momentum of this car. So that during the next lesson we'll be moving ahead to the Newton's. We look at now the Newton's second law of motion, whereby now we'll state the Newton's second law of motion and look at the relationship that exists between force, mass, and acceleration. So thank you for being attentive during the lesson. Let us meet during the other lesson.